We're doing F plus G. I got it. Maybe. Okay, so if you have F plus G, this is going to be x over 2x minus 1 plus x squared. I'm going to plug in a 2. So 2 over 2 times 2 minus 1 plus a 2 squared. Guys, you can make this really hard on yourself, or you can make this really easy on yourself. To make this really easy on yourself, you literally just go grab your calculator, and you go in here, control division key, and this is going to be 2 over 2 times 2 minus 1 plus 2 squared, and hit enter. What does it give you? 14 over 3. Like, that is showing work. You know why it's showing work? Because I understand that you know how to calculate. I'm not testing you over order of operations. I'm testing you over, do you understand what F plus G is, and I plug and chug into it. Oh, well, what's that? So F minus G. So again, this is going to be x over 2x minus 1 minus x squared. So this is going to be a negative 6 over 2 times the negative 6 minus 1 minus a negative 6 quantity squared. Now, do I need to have those parentheses around that negative 6? I absolutely do, because y'all are going to not square that negative 6. Squaring that negative 6 makes it a positive 36. So again, this is going to be negative 6 divided by, actually, control division key, negative 6 divided by 2 times negative 6 minus 1 minus parenthesis and negative 6 squared. Enter. And that's where you're going to get the negative 462 over 13. You worked way too hard on that problem. Would you agree with me?
Yes.
Okay? Think about what we're testing you over and what your goal is. Okay? Next one. Here we go. Same two functions. I'm doing f times g and f divided by g.
Can you put his name on it? And it's going back into it.
Oh, no, not so much.
Okay, Mr. Bell. Robert.
Are we done yet?
No, I don't understand.
You have to simplify that. You cannot leave it like that. You must simplify it. You have to simplify this. You can't simplify that. This is going to be f times g, so this is going to be x over 2x minus 1 times x squared. Put this over 1. So marry the tops. X times x squared is going to be an x cubed over 2x minus 1. That is your simplified f times g. Do we understand that? That is f times g. However, f divided by g, f is x over 2x minus 1 divided by an x squared. Did you see how I wrote that horizontally? Turn that into a fraction. Turning that into a fraction means I'm actually dividing by a fraction, so that means I'm multiplying by its reciprocal. Do we see that? And then look diagonally if you can cancel anything out. This x goes away and this x squared turns into an x. So what I have is 1 over x times 2x minus 1. Do we see that, yes or no? We good? Keep going. What are you doing in these problems? You're plugging a function into a function, right? You're plugging a function into a function. So, what is g defined to be here? So I am taking g of x and I'm putting x squared in place of it because that's what it's defined to be via up there. Yes? Can you see that? Now I'm taking my f function. Why am I taking f? Because that's what the x squared is attached to, yes? So f is defined to be x over 2x minus 1. And every place I see an x, I'm going to plug in what? X squared. So this is going to become an x squared over a 2 times an x squared minus a 1. To simply give you x squared over 2x squared minus 1. Now here's my question for you. Can I do anything with 2x squared minus 1? You cannot cancel out the x squares. You cannot cancel out the x squares. Okay? This x squared in the denominator is attached to the 2 by multiplication and attached to the 1 by subtraction. The head is 2x squared, the body is the minus 1. The only thing that cancels out with 2x squared minus 1 is 2x squared minus 1. The whole quantity. Do we all understand that? So this is essentially done. Do we understand that? Yes or no? Go to this side. G of f of x. Well, how do you do g of f of x? That's g, and what is f of x understood to be? X over 2x minus 1. What is the point of the g? The g tells us which function I need to grab. I need to grab the x squared function because that's what g is. And every place I see an x, I'm going to plug in that function. And I'm squaring that. Now, when you have your fraction and you're squaring it, do you understand that that's 2 of them written down beside each other? That's x over 2x minus 1 times x over 2x minus 1. Yes? Do you understand that? So what's x times x? Over 2x minus 1 quantity squared. Is it going to do any good for me to FOIL that? Could I FOIL it? I could, but it's really not going to change what the problem is. All right, so if you wanted to FOIL this up top here, you could get a 4x squared minus, inner gives me negative 2, outer gives me negative 2, minus a 4x plus a 1. These two are equivalent. We understand that. Those two are equivalent. It does not benefit me to FOIL, but if somebody put that down, you would not be wrong. We all understand that problem. I'm not going to indicate. I'm going to let you guys know when you're done. You need to understand, does it help you, does it not help you? That's what the whole test is over, okay? Am I going to penalize you if you go too far? Probably not. Okay. I'm going to do f of g and g of f. All right, we have to do the domain of this. So how do you do the domain? So I'm going to go ahead and we're going to see what we have here. The domain of f of g of x is understood to be x squared over 2x squared minus 1. Would you agree? That's what f of g of x is. So how do I find the domain of that? Yeah. So I'm going to take 2x squared minus 1. That cannot be 0. So 2x squared is equal to 1. So x squared is equal to 1/2 or cannot be 1/2. So then you're going to take the square root of the top and the bottom. So that's x cannot equal 1 over the square root of 2. And you actually have to have plus or minus. Now, I'm not worried about this one because this is a harder one. Plus or minus the square root of 2 over 2. On the test, you won't have anything as hard as that. That's rationalizing. Remember back in algebra 2, you had to rationalize. You multiplied by this. I'm not worried about you doing that. I'm not worried about you doing it. I already said that, so take a chill pill, everybody. Okay? But that would be what you would do to find the domain. Okay? Okay, the domain of this one. This is going to be x squared over 2x minus 1 quantity squared. Okay? What you need to know is 2x minus 1 cannot be 0. So x cannot be positive 1/2. So my domain, x is an L with the reals, such that x cannot be 1/2. Okay? It's square.
No. Oh, what? F, G. Oh, how to say that?
This is the only domain because x squared is not, there's no domain restrictions on g of x. She's saying, shouldn't I be doing the domain of f and the domain of g to be able to get the composition of them? This has no domain restrictions. The only domain restrictions on f is it can't be 1/2. Does that make sense? Okay.
Oh. Can we go over that zero thing again, like in the graphic I was telling you about? Like it, I understood it when you said it yesterday, but now.
You mean this right here? G of f of 0?
I think so. Where it says zero when you're trying to find everything.
Okay, f of g at -2. What does this say you're supposed to do first? Work from the inside out. So what do you do first? I'm going to take my g function, which is x squared minus 8, and every place I see an x, I'm going to plug in -2. So this is -2 squared minus 8. Well, what is -2 squared? So I'm going to take 4 and subtract 8 from it, and that's going to give me -4. What does -4 equal? What does -4 equal? That is g at -2. So I can make a substitution. So I'm going to do f at -4 now. I'm going to say this. Are we all listening? If you are confused, chances are you are not on top of your homework. Chances are your homework is not done. You're going to be confused if your homework's not done. I mean this kindly and politely. If I'm reviewing and the test is tomorrow and you still have not completed all your homework, that's on you and you probably are not going to do very well on the test. You cannot expect to learn everything the day before the test. That is not what a review is meant to be. A review is meant to refresh you and let you know what is going to be on the test and remind you of every assignment that you've already completed. Not help you to remember how to complete the assignments so that you know how to do the homework before the test. Do we all understand that? So if I have done grading and I have all my grading done, if you come up to me and you say, Mrs. Yoder, can you help me complete my homework? I'm going to struggle with that a little bit. Will I help you? Yes. But I'm probably not going to help nearly as much as what somebody who has been doing their homework every night and is struggling with a few problems. Okay? You got to try some every night. Like you have to try some every night. I'm not saying you got to complete the entire assignment every night, but you have to try some from every section of the homework so that you know what's happening the next day. Yes? Okay, so now f at g at -2, g at -2 is -4. So I'm plugging that in place. I'm replacing g at -2 with -4. So I'm going to take my f function, which is the square root of 2x plus 5, and every place I see an x, I'm going to plug in -4. So that's 2 times -4 plus 5. That's -8 plus 5, and that's the square root of -3. Now tell me, folks, can you take the square root of -3? No. So is this a real number? No real number. Do we all understand that? Okay? If you wanted to finish this, this would be I square root of 3. Do we understand that? Okay, now over here, g of f of 0. What do you do first? So I'm going to do f at 0. So f is defined to be the 2x plus the 5. So that is 2 times 0 plus 5. What is 2 times 0? So what are you left with is the square root of 5. Do we see that? Yes or no? So what is the square root of 5 substitution for? F of 0. So now you're going to be doing g at the square root of 5. So that's going to be g at the square root of 5. G is defined to be x squared minus 8. Do we all see that? Yes or no? So you're going to put the square root of 5 inside there, square that, and then minus 8. What is the square root of 5 squared? 5 minus 8 is negative 3. Do we all understand that? Yes or no? Okay. Now, we have reverse composition. Go ahead and do these on your boards. I'm telling you that f of g of x is equal to h of x. I want you to find f and g, write it on your boards, and make sure you know which one is which. Are we ready? Excellent job, Chase. Good job, Allie. Can you hold that up one more time, Allie? Yes, I'm sorry. Okay, I want you to work from the inside out. This says that f of g of x is equal to h of x. So remember, the inside function is g of x. So what is the inside function here? X plus 4 is the inside function. And in order to be an inside function, you have to replace the inside function with what letter? Once you know what the inside function is, you pull it out and replace it with what? X. So that means f of x is going to be the square root of x plus 2 square roots of x minus 9. Do we all see that? Yes or no? We good? Same thing, but this time it's g of f is equal to h of x. So please make sure you label your functions appropriately.
Did I say squared or cubed by x?
Cubed, I'm sorry. This is cubed. Can we see? Is that better?
Thank you.
Uh-huh. Yes. 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 Tell me what f and g are. I need to know which one is which. Correct. Good job. Okay. So this says g of f of x. So what is my inside function? X minus 2 is my inside function. What is that equal to, f or g? This is equal to f of x. Why f of x? Because f of x is on the inside, so therefore that is the inside function. So what is left to be g of x? Negative 2/3 x cubed plus 2x minus 6. Do we understand that, yes or no? Excellent. Now, these next ones should be relatively easy for you. Up, down, left, right, stretch, compress, reflect. Up, down, left, right, stretch, compress, reflect. Tell me the parent function and tell me the transformations. And just leave it on your board because, seriously, it's going to take too long for me to read every person's board. Yeah, just wait, Amanda. No, it's okay. In the event that you are forgetting anything on the day of the test, this blue poster back here helps with the transformations. It shows you. So the blue poster back there if you have to go sharpen your mechanical pencil and take a lap around the room, get it? No reason whatsoever in the world to sharpen a mechanical pencil. I'm with you here. Okay, what's my parent function? X cubed. What's the negative? Reflect over X. Why not Y? Because whenever you reflect over Y, you replace X with negative X, so it would be on the inside of the parentheses. What does the 2 do? Stretch 2. Left 8. Down 7. Do we all understand how I write that there? Next, go. Do the same thing. I don't need to see the boards. I just need to make sure that you have it done. Don't make it harder than what it is. You got this. This problem is here to screw with your head. Okay? And the reason why it's used to screw with your head, no, because you already had it down. You already had it down. Had I not said it on the test, you would have left it like that. No. This should be over here. So this is negative 1/2 absolute value of X plus 5 plus 8. Okay? So what you should have had is your parent function is going to be the absolute value of X. It's reflected over X. It's a compressive half. It is going to be the left 5, and it's going to go up 8. How many people did I get on this? Okay, how many people got it correct? Oh, you don't count. You can't say you caught it if I reminded you. Uh-huh. Good job. Next, again. When in doubt. So if I'm allowing you guys to have the graphing calculator, should anybody miss any of these transformations? No, because if you have time, you should be plugging and chugging into your calculator and making sure that what you have written on paper is the correct transformation whenever you graphed it out. Are we ready?
Yeah.
Yep. Okay, parent function. 1-armed gambit, which is the square root of X, the negative. Reflect over X. Stretch of 7/5. Why is it a stretch and not a compress? Because the top of the numerator of the fraction is larger than the denominator. So it's top heavy, meaning it's larger than 1. Do we all understand that? Okay. How many people did I get? How many people wrote compress? Got you guys. Okay, then we're going to go to the left 8 and up 10. Do we understand that? Excellent. Keep going. How rude of Mrs. Yoder. It's just so mean. Guys are something else.
I think I got this one together.
I'm not tricking you?
No.
I don't trick students.
You probably are tricking me.
I don't trick students. Okay. What is my parent function? X squared. What's the 2 do? Up to. Yes, do we understand that? What's the negative? Reflect over X. Stretch 7. Left 5. I'm gonna get you. One way or another.
I see what you're trying to do.
I'm gonna get you.
Oh.
Swiffer is forever better than that.
Well, Blondie in the morning. Nope. Well, wait. Whoa. Nope, you missed one thing. You're gonna be so mad at yourself. When in doubt, graph it out. When in doubt, graph it out. You have a calculator right in your beautiful little hand. Please graph that baby. We all agree that the parent function happens to be the square root of x. I told you that the one funky looking parent function is always the square root of x, right? Everybody probably got up 8 because you know I'm going to get you up. Everybody got that it's reflected over the x-axis because it's negative there, and everybody probably got the compressed 2/3. What you probably did not get. Okay, so when in doubt, graph it out. What I'm going to tell you is this right here, that is inside here. If you were to go ahead and pull out a negative, that's going to be x minus 5, which means I'm reflecting over the x and the y, and I'm actually going to the right 5 units. And if you graph it, you'll see that. How many of you went left 5? I know you're not the only one, but I'm telling you on the test, you need to watch those. So the test is tomorrow. Look at me, eyes on me. You need to be prepared for tomorrow's test. Everything I've covered is on the test tomorrow. I know that you guys will probably do very well in the up, down, left, right, stretch, compress, reflect. It's going to be the adding and the composition and the subtracting, multiplying, dividing two functions where it's going to get a little sketch. Okay? What's that? I mean, at least we're honest about it.